are you doing?
I'm filtering this water through this paper.
Oh,
Today, we are going to talk about filters, but not these filters, but active filters.
For the first order low-pass active filter, if you want to design the circuit, first you need to know how to draw the circuit. And you need to find the value of unknown, which is the resistor component. For every RC active filter, the C is always smaller than 0.1 micro. And how to find the value of R? R is equal to 1 over 2 pi FHC. And RF and R1 can be found using the formula of A naught. The frequency response dot plot, the graph will always constant until it reaches FH, and it will decrease with the rate of negative 20 dB per decade. First order high pass active filter. The process of designing, you can refer back to the first order low pass active filter. But you need to change FH to FL. This is the circuit of the first order high pass active filter. And this is the frequency response dot plot of the high pass active filter. The second order low pass active filter, it has two RC networks, which is R3, R4, C1 and C2. To find R3 and R4, you need to use the formula of KLP over 2 pi FHC. To find R1 and R2, you need to use the formula of A naught equal 3 minus alpha. In high order active filter, the value of KLP and alpha, you need to refer to the table according to the filter type. The second order high pass active filter, the process of designing, you can refer back to the second order low pass active filter. But you need to change FH to FL. This is the circuit of the second order high pass active filter. And this is the frequency response dot plot of the high pass active filter.
Moving on to higher order filter. Higher order active filter can be built by cascading multiple stages of second and first order active filters. The third order filter, one should cascade the first order active filter with the second order active filter in series. The transfer function for third filter is this. Also, take note that this formula is for the pass band gain. This circuit is an example of a third order low pass active filter. We could get the R value from the first stage by applying this formula, where the constant values are taken from the Bessel table. For the R reference, we could get the value by multiplying R with A1, where A1 is equals to 3 minus alpha. To calculate R1, we take the R reference divided by A1 minus 1. Followed by the second stage of this circuit, formulas to calculate the R and R reference value are the same, but take note that the A1 from the previous formulas need to be replaced with this formula. Proceed to active band pass filter. It can be easily constructed by cascading high pass and low pass filters. This circuit is an example of a band pass active filter. Take note that the FH of low pass filter must be higher than FL of high pass filter. There are two classes of band pass filter, the wide band pass filter and narrow band BPF. Both can be differentiated by its Q factor. Wide band has Q factor lower than 10, narrow band has a Q factor greater than 10. To calculate the Q factor, we take the center frequency divided by the band width. FC can get by applying this formula. And bandwidth we can get by applying this formula, FH minus FL.
So, do you understand about this topic?
Yeah, very clear explanation.
She understands. How about you?